Okay, guys, I'll give you a minute just to copy those down. Don't do anything with them. Okay, just copy them down for right now. Okay, because I haven't told you what I want to do, which actually is right now. I just want you to copy them down. Okay, I want to use them to review what we talked about yesterday. All right, so going to review what we talked about yesterday. We went over 5 reaction types. Okay, and we went over how to balance those reactions. All right, so obviously the reactions on the board are not balanced. I haven't put in any big numbers in any of them, any coefficients. Right? But what we want to do here is just kind of review the 5 types. So the first one here, okay, so number 1 is what type of reaction? Synthesis reaction. 2 elements are going together to form a single compound. All right, is that balanced?
No.
No. What should I balance first?
Chlorine.
The chlorine. Right now it's really the only thing that's out of balance, and it's the biggest number, which is the rule we use for all reactions except?
Combustion.
Right. Okay, so I'm going to need to put, do I put a little 2 here, or do I put a big 2 in front?
Big 2.
Right, I can't change the little numbers, okay? So I put a big 2 in front, but when I do that, while that balances my chlorine, it gives me 2 sodiums as well. So what needs to go here?
2.
Right. Okay, what kind of reaction is the second one?
Combustion.
Okay, what are the rules for combustion? Alphabetical and?
If the carbons are even, you do them first.
Right, and if you have, no, sorry, you always do the carbons first, but you start with a 2 if there's an even number of carbons. It's the rule of 2, okay? Remember, I did the Yoda voice yesterday, okay? It's supposed to help you remember, guess that one. Fell flat. Okay? All right, so we're going to start this one with a 2, all right? So 2 times 6 is how many? 12, all right, so we had 12 carbons here. 2 times 14 is 28. What needs to go here? 14. Okay. You can usually just look to the number on the hydrogen for what number to put there in this situation. Okay. And then I can do the oxygens. So here in carbon dioxide, I have 12 times 2, which is 24 oxygens, plus another 14 oxygens in the water for a total of 38. Okay. 19 times 2 is 38. Okay. All right. The next one, what kind of reaction are we looking at there? Single replacement. We have an element, it's reacting with an ionic compound, it's making a different ionic compound and a different element. And in a single replacement reaction, that lone element always replaces the part of the ionic compound that it is similar to. Okay, so in other words, it's going to swap the metals. Okay, so what am I looking at for balancing here? What should I balance first? Okay, so I mean, I've got 3 in there in 2 places, agreed?
Yes.
All right, and we always say start with the biggest number first. And up until this example, I said it really doesn't matter. But that's because in all the situations we've done up until now, the 2 that had the same number also had the same charge. Okay, but in this case, they don't have the same charge. Lithium is a +1, calcium is a +2. Which one will have a bigger effect on the overall reaction? The calcium. So if you got the same number in 2 places, go with the bigger charge first. Okay, it doesn't usually matter too much, but there are the odd time where it does. Okay, if you forget that, you'll just end up at the end and go, oh crap, that didn't work, and then you have to erase your numbers and start with the other one. Not the end of the world, just time consuming. Okay? All right, so I'm going to start with calcium. There are 3 over here, so what should I put here?
3.
Okay, and then I've got 2 nitrogen here, but only 1 here, so what needs to go here? Okay, and this one probably would have worked out no matter which way I did. Okay, no, sorry, it wouldn't have, because I would have put a 3 over there and it wouldn't have worked. Now I've got how many lithium? 6, so what needs to go here?
6.
Okay, are we good now? All right, so that's why I wouldn't have started with lithium on that one. If I'd have started with lithium, I'd have put a 3 here, and then got to a point where I couldn't make it work. And then I'd have had to start over. Okay, start with the biggest charge first, and generally works better. All right, the next one, what kind of reaction are we looking at there? Simple decomposition. All right, so in that case, a single compound, ionic or molecular, is breaking down into its constituent elements. The big thing with that one is you got to remember, probably going to get special elements being formed, okay, those molecular ones that end up as 2s, most of them. 4s if it's, which one comes as a 4? Phosphorus, which one comes as an 8? Right, okay. So in this one here, looks like the nitrogen's already balanced, but my biggest number is fluorine anyway, so that's what I'm going to start with. I've got 3 on this side, 2 on that side. How do I make that balance?
2 and 3.
Right, lowest common multiple of 2 and 3 is?
6.
Okay, so that's what I got to do. I'm going to put a 3 here and a 2 here. All right, now when I do that, my fluorines are good, but now I have how many nitrogen? 4, so what needs to go here? 2. All right, ringing a bell?
Yep.
And then our last one, what kind of reaction is that? Double replacement. I don't think this reaction would ever occur because I don't think either of those silver compounds actually exist, but I just started throwing things together. Okay, so we've got beryllium cyanide, silver carbonate, probably not a thing, silver cyanide and beryllium carbonate. What should I start with? The silver, yeah. I mean, silver or cyanide, they both are a +1 or a -1. They have the same charge. They're going to affect it equally, okay? And they're both 2s. So if I've got 2 silvers here, and I put a 2 there, that also balances my cyanide, and everything else is a 1. Okay, 1 beryllium, 1 beryllium. How many carbonates?
3, 1.
Watch out, okay? Watch out on those polyatomic ions. This is 1 carbonate. This is 3 carbonates. Okay? Always that's the thing that gets people on balancing. Okay? There's 3 oxygens. I will absolutely not argue that. Totally. If you want to balance all the elements individually, go right ahead. It's a lot longer process. Okay? Since carbonate stays together, it's best to balance it that way. Okay? All right. So now it's balanced. Okay? Questions? We're going to practice a few on our own here. Okay, I didn't make you write any of these out in words, but that is also something I'm going to ask you to do, just to practice the writing of names. Okay, that's a part of what will be on your assignment on reactions. Not next week, even the week after. Okay. Come on. Okay, I would like you guys to try those 3. Okay, type, balance, write it in words. Okay, what kind of reaction is the first one? Simple decomposition, right? Okay, if I'm writing that out in words, this would be trinitrogen dioxide. What's this stuff? Nitrogen, right? It's just the elemental form of nitrogen. Okay, and this stuff? Oxygen. Okay, now I gotta balance it. What should I balance first? Nitrogen. Right now, it's the only thing that's out of balance, right? The oxygens are 2 and 2 already. All right, so 3 and 2. 6. Okay, so I'm going to put a 2 here to give me 6, a 3 here to give me 6. But putting that 2 there gives me how many oxygen? 4. All right, 2 here. Good from there. Okay. How many people have done the second one? Okay. All right, what kind of reaction are we looking at? Single replacement. Okay, and this would be calcium reacting with iron 3 chloride. Be surprised how often people forget that after we've been not doing naming for a while. Okay, and that'll leave us with iron. Do I need to put a Roman numeral on that? No. It's an element now. Do elements have charges? No. Okay, that's a very common mistake. Okay, people got the Roman numeral on this side when it's part of a compound where it is an ion, and then over here when it's an element, they feel like they got to put a Roman numeral there as well. You do not. Okay, Roman numerals are only needed in ionic compounds, not on elements. Okay, and this one here would be calcium chloride. Okay, gotta balance it. What should I balance first? The chloride, yeah. That's the only thing that's out of balance right now, right? Okay, so I got a 3 and a 2. Lowest common multiple? 6. Okay, a 2 here and a 3 there take care of my chlorines, but as soon as I put those numbers there, they also apply to the other part. So now there's 2 irons, so I need to put a 2 here. Irons are balanced. 3 calciums, put a 3 here, and my calciums are balanced. Okay. Okay, how many people have done 3? Okay, let's look at 3 then as well. All right, what kind of reaction are we looking at? Okay, do I need both rules for this one? Yes, I do. We just did that one.
We did.
Well, that was good. I was really on the ball when I made up that other one. Okay, well, hexane plus oxygen. So all you had to do was look at the example, and you had all the answers for this one, except obviously for writing it out in words, carbon dioxide and water, which was probably not challenging at all. Okay, just so that you're aware, I think I've mentioned this before, but anytime you see water written like this or written like that, just write water for the name. Okay, that's the one thing you can use the common name for. Okay, water. Don't bother writing dihydrogen oxide or hydrogen hydroxide or, okay, or dihydrogen monoxide. Just water. Water's okay. All right, balancing this. Rule of 2. Okay, 12 and 28 and 19. Okay. All right. Questions there? I'm going to give you a 5-minute break before we do a couple more of those. Okay, guys, I would like you to try the next 4 that are on the board. Now, you'll notice that the second 2 are written out in word form. That makes them trickier. Okay? Because now you've got to remember all the dropping and swapping and all that other important stuff, special elements and things like that, okay, when you're writing it out in formula form, because you obviously do not balance an equation when it's in word form. Okay? So you'll have to write it out in formula form and identify the type and balance.
Do you want us to write the word form below the...
Yeah, for these 2, write it out in words, okay? But for the ones that are already in words, write them in formula form so that you can balance them. All right, let's look at 4 and 5 here, guys. So for number 4, okay, what kind of reaction am I looking at? Synthesis. I got 2 elements combining to form a single compound. Okay, so synthesis reaction. It is chlorine plus lithium gives lithium chloride. Okay, and if we're balancing that, we should start with the chlorine because it's the only thing not balanced. We'll have to put a 2 there to balance it, which means we also have 2 lithiums, so we go back, put a 2 there, that one's done. Okay. For number 5, what kind of reaction are we looking at? Double replacement. Yeah, 2 ionic compounds are reacting and the metals are switching to give us 2 different ionic compounds. So we have magnesium chloride, okay, plus cobalt 3, yeah, nitrate, okay, giving us magnesium nitrate. Plus cobalt 3 fluoride. Now, in the future, when we're predicting our products, okay, it is important to note that if you start with cobalt 3, it'll be cobalt 3 on the product side. You're not going to switch cobalts from one side of the reaction to another. So if you've determined on the reactant side that it's iron 2, it's iron 2 on the other side. It'll always be the same Roman numeral on both sides of the equation. Otherwise, you're kind of going against what Dalton said. You're kind of changing it into something else. It's still iron, but you've changed its charge, which you can't do. Okay, it starts one way and finishes that way as well. Okay, then we gotta balance that thing. Ugh. What should I start with? Yeah, you can start with nitrate or fluorine. They're the same charge and they're both a 3 on one side. So I'll start with cobalt just because it's the nitrate just because it's the closest one. There's 3 over here and 2 over there. Lowest common multiple? 6. Okay, so I put a 2 on this side and a 3 on this side. That 2 also applies to the cobalt, so I'm going to put a 2 there. That 2 also applies to the fluorine, giving me 6. So I got to come over here and put a 3 in front of this to make my fluorines work. That 3 also applies to, oh, nice. It worked. Okay, yeah. Okay. Always a good sign if the last number you write in works with the other ones you've written in. And it means you did it right along the way. Okay, how many people have done number 6? Okay, let's have a look at number 6, just because it's our first one where we're going from the word equation to the formula equation. Okay, because there's lots of stuff we have to remember for that. So we got copper 2 nitrate. So ionic compound, they tell me the charge, it's with nitrate. Okay, that's a -1. So when I drop and swap, I'm going to have this. CuNO3 It's reacting with magnesium. Formula for magnesium is Mg. Always make sure you leave room for your coefficients when you're writing it out in formula form. All right, and that's going to form magnesium nitrate. So Mg, 2 plus, NO3, okay, which is a -1. So sorry, I got on the brackets a little early there. Okay, but that'll be our formula. And copper. Copper metal, which just means copper as an element. Okay. All right, are all my compounds okay? They're all dropped and swapped. Do I have any special elements I need to worry about? Right, copper's a metal, magnesium's a metal. They're not going to be 2s and 3s or anything like that, right? Okay, so now what do I have to do? Yeah, balance and identify the type. What type? Single replacement. Okay. Okay, and now I got a balance. Yeah, looks good. Okay. Every once in a while you get one like that. Okay. Now, if you're balancing and it's fill in the blank, because you're going to get some that are fill in the blank, should you leave it blank or should you write 1s in all the blanks?
Once.
Yeah, because otherwise I don't know whether you didn't know how to do it or you knew it, because you didn't write anything in there. So if it's fill in the blank, go 1, 1, 1, 1. Otherwise it looks like it's not done to me. Okay, and I don't know which is true, whether you knew how to do it and recognized they were all 1s, or you had no idea how to do it and left it blank. Okay, so if it's fill in the blank, put 1s in the blanks. Okay, how many people have done number 7? All right, let's look at 7 here. Okay, what kind of reaction do we have? Combustion. It's really hard to hide combustion reactions in word form because you always include the word burns. Okay, so they're like kind of giveaways. So C12H26 is reacting with oxygen to produce carbon dioxide and water. Okay, we got some big numbers here. I'm going to have to do some calculating on this one. Do I have to apply the rule of 2?
Yes.
Oh man, that makes it even worse. I already had big numbers. Now I have to double them all. Okay, so 2 times 12 is how many? 24. All right, so I got 2 dozen carbons on that side. Okay, 2 times 26 is 52. But I only need to put a 26 there because 26 times 2. Now I've got to do the oxygens. So 24 times 2 is 48 oxygens. Plus 26 more is 74. 2. 74. 74. Okay, that's going to mean 37?
Yes.
Yeah, I'm on a roll today. Okay. Questions on that one? So other than having to, have big numbers there, okay, can I make any of those numbers smaller? I can't divide 37 by 2. Okay, so we're stuck. Those are the big numbers. We're stuck with them. That's how that one goes. And the bigger that the compound gets, the more oxygen and the more carbon dioxide you're going to get out of it. okay? This is why, guys, in terms of kind of like environmental concerns, pollution controls, things like that, that they, for a while, converted vehicles to run on propane, okay? Because propane puts out less carbon dioxide than what's in gasoline, which is octane, okay? If you've ever gone up to the pump, okay, there's a rating on all the gasolines. Regular gasoline is 87 octane, mid-grade is 89, and premium is 91 octane. They're the different amounts of the pure stuff in the fuel. Okay? So the more of it, the bigger that fuel molecule is, the more carbon dioxide and water you're going to produce. So if you converted something that normally ran on octane down to propane, okay, it would produce less carbon dioxide. It also doesn't produce as much power, so there's a trade-off. It's the same with all the fuels that are blended with ethanol now. Okay, like all the gas stations you go to now, they'll say right on the pump that this may contain up to 10% of ethanol. Okay, it's another effort to burn cleaner and reduce the amount of carbon dioxide that is produced. And in fact, some vehicles will run on an even lower grade of fuel called E85. Okay, which is 85 octane fuel with more ethanol in it. Okay, and again, you lose power. It's not as you don't get as good a gas mileage because your car is burning more of it because it doesn't generate as much power in it.
Propane, in the event of an accident, it's not very safe to have a pressurized canister.
Yeah, exactly. Yeah, automotive propane.
Gas.
Yeah, that was kind of the thing about it.
You
Is
can't
you
put
couldn't
propane
park in a
propane
parkade
barrels,
either. You couldn't park underground if your car ran on propane. There was a lot of
There's cases of like
downside.
accidents and those would build.
Yeah, yeah. So it's a big deal to have a pressurized
Did you have a leak
container of fuel.
fuel?
So generally we don't do that.
Okay.
All right, making sense so far? Okay, so I'm gonna have you try a few more of these ones that are word to formula, just because you have to do a little bit more thinking with those. Okay, so try 8, 9, and 10 there. So 8 and 9 both have like a little thing that we kind of need to be aware of when we're writing out reactions from word to formula. Okay, so for number 8, we'll start out with, okay, it's obviously lithium with nitrogen, which is, this is a -3, that's a +1, so we're gonna have Li3N, and it's breaking down into nitrogen and lithium. What do I need to remember about nitrogen when I write this? Right, it's one of our special elements and comes as a 2. If I don't do that, I'm not going to balance it correctly. Okay, so it's one of those reaction types where I have to remember my special elements. Okay, now when I want to balance this, okay, this is another case where if I go with the biggest number, I'm probably going to end up having to start over. Okay, this is one of those very rare occasions where that would happen. If I just go, oh, I'll put a 3 here, then I look at my lithiums and go, oh, that won't work. Okay. Because if I put a 3 in front of the lithium, and then come back here to balance nitrogen, I have to put a 2 in front of it, which gives me how many lithiums instead? 6. Okay, so I'm going to start here with this 2. Okay, that's going to give me 6 lithiums, and it's going to balance my nitrogens out. Okay, and it happens sometimes. It doesn't work the first time. Okay. All right, now number 9. What I want to show you with number 9 is that you can use the fact that you can write water 2 different ways. So we got hydrogen sulfide. Hydrogen sulfide, so that's H with S. This is a -2, this is a +1, so we're looking at H2S. Okay, reacts with calcium hydroxide, CaOH. This is a -1, this is a +2, so we'll have CaOH2. And that's going to produce calcium sulfide, so Cas, and water. Okay, so this is a -2, this is a +2. That's why I wrote it that way. Okay, now here's why I would want to write water like this instead of writing it as H2O. Is it easier for me to track where the parts of it come from if I write it like that in this reaction? It is. Okay, if I write it as H2O, then I get confused with where the H's came from. Okay, because if I keep OH together, I know exactly where it came from on the reactant side. Okay, so when you're dealing with a replacement reaction and water's involved, you're probably better off to write it as HOH okay, if it came from a hydroxide containing ionic compound on the other side. In a combustion reaction, there's no reason to do it, okay? The hydrogens and the oxygens are separate the whole reaction, so it's fine. Okay? All right, so in this one here, okay, I've got two hydroxides, so I'm gonna go over here and balance that. That happens to make my hydrogens work, okay? There's two over here, all right? One calcium, rest of the reaction is good. All right, what kind of reaction is this? Double replacement. What kind of reaction was that one? Simple decomposition. Okay, how many people are done number 10? Okay, perfect. Let's go over that one and then we'll call it a day. Okay, so phosphorus. What do I have to remember about phosphorus? Right, special element. Very special. Comes as a 4. Okay, reacts with oxygen. Do I have to remember anything about oxygen? Also special. Okay, to produce triphosphorus, P3, dioxide, O2. All right, well my oxygens are already balanced, but my phosphorus are a mess. Okay, what's the lowest common multiple of 3 and 4? 12. Okay, so put a 3 here to get 12, put a 4 here to get 12, but that gives me how many oxygen? 8. Do I have 8 over here now? Then I'm good. Okay, what kind of reaction is that? Synthesis. All right, how are we feeling about this stuff? All right, we'll probably spend tomorrow's short Friday class just practicing this much, and then on Monday we'll probably move towards starting to predict the products of a reaction.